Hello, welcome to multivariate statistics and machine learning. The purpose of this video is to guide you through some of the materials available for you to do this course. And also I will give you a little bit of an overview about the content of this module. So let's start with the material. So given that you're already here watching the video, I assume you already went to Blackboard or to my course homepage and downloaded the weekly learning plan and probably also some of the other materials. So I'll show you how to do this. Let's go to the web page. So this is my personal web page, and this is also where you can learn about me if you want to know about what I'm doing other than teaching this course. So this is the front page, and directly in the front page you see this link here. So MATH38161 multivariate statistics and machine learning. If you click on this link, you'll get directly to the homepage of this course. So I would recommend you to bookmark this page so that you have easy access. The same content you'll find also on Blackboard, and actually there's a link here to Blackboard somewhere. It's here. So if you click on the Blackboard link, this will take you to Blackboard, and actually on Blackboard there's more information that is not publicly available, of course, including previous exam papers, my feedback to you, and so on, and of course also the coursework and the instructions. So how does this whole thing work? So this is a year 3 course. It's 11 weeks, so for every week you have a learning plan, so you can download the learning plan here. So all of the material is also on Blackboard if you prefer that. So we have a weekly learning plan. In this learning plan I tell you which videos you should watch every week, and then we have the lecture notes. The lecture notes are available in PDF format or as an online format. So if you click on online, then you can actually browse this in your browser. And some people may find this more convenient than looking at PDFs. It depends what you're used to. I think this is actually quite useful when you're on an iPad or on your phone. So this is why these two versions are available, and in the weekly learning plan I'll tell you exactly which part of these notes are relevant in each week. So this is your job, because this year this course is taught in a flipped classroom manner. So you first read and study the material, and then we discuss it in live sessions. So these videos are here to support you reading these lecture notes. And especially in the later chapters you will have to do some further reading as well, but I'll guide you to that once we're in the last 3 weeks. That's when this will happen. So the weekly learning plans, there's a weekly learning plan, lecture notes, and then also download the worksheet. So every week there is a worksheet with questions and problems, and also with solutions. Obviously you should try to understand the solutions, that's why the solutions are there, but first you should try to solve it in your own time. So then you'll find here the link to the videos, but since you're watching this video I assume you already found the videos. So at the time when I was filming this, the slots for the various live sessions weren't finalized, so there will be a review session. So I will do a live session. It will be either on campus or online, or a tutorial session either online or on campus. That depends on the current situation, obviously, and an office hour. So the office hour will definitely be online only. So I will update this as soon as we know more. So certainly when the term starts. So the whole thing starts in the week of the 5th October, and then it runs for 11 weeks with no breaks. and in the study guide you get to, you can find out what you have to do each week. So then you're most welcome to send an email to me if you have any comments or questions or corrections. But before you do this, I would like to ask you to check this frequently asked questions, because this is a reasonably large class and often you have, of course, the same questions, and so it's worth checking before you ask a question that I've already answered many times. So if I answer a question many times, I will put it into the frequently asked questions. So that brings me also to the assessment. In week 7, and that's hopefully this is not going to change, but this is also subject to approval from the faculty. So my plan is that there will be a coursework announced in week 7, end of week 7, and then you have to submit the coursework in week 9. And this consists of a small problem that you have to solve, and you have to write a little report, and the expected time you should budget for this is 10 hours. And then there will be an exam in January, and this is also the precise date of this exam will also be finalized. So if you bookmark this homepage, then you can find out the times. And equivalent, you can also, if you prefer, you can also look at Blackboard. So that's the background. So it's flipped learning, and you work through the lecture notes, you work through the examples, and then there will be live classes where we'll discuss in an interactive fashion the worksheets, and there will be a lecture where I review what has happened this week in the videos. So how will I do the lectures? That's easy, because we'll just do it like in every math class, namely we use a visualizer. So it will basically work like this. So I'll do the usual math thing. So I'll just write a formula. So 1, 2, 3, 4, 5, and then we will discuss the methods just as usual. So it's hopefully almost like being in the lecture hall, where I'll teach and you'll be sitting and watch me using a visualizer. So this is now the virtual visualizer, and I can use this now to list the topics. So multivariate statistics is of course a very exciting area in statistics, because everything of any interest in statistics is of course multivariate, because the whole purpose of statistics is to find out how things are related to each other. So if you want to make predictions, or if you do a regression, or you try to find out, you have a complex set of variables that you're analyzing, you would like to find out which variables are relevant for predicting other variables, or you just want to know how these things interact, and then you automatically end up in the realm of multivariate statistics. And of course, naturally, multivariate statistics is bordering, the more deeper you go into multivariate statistics, then you end up doing machine learning. So machine learning uses a lot of techniques from multivariate statistics. So this is why this course has several parts, and the last part is dealing with some techniques known in machine learning. And from my perspective, machine learning is high-dimensional multivariate statistics with nonlinear models, whereas more classical multivariate statistics focuses on low-dimensional and linear models. Of course, we start with the classic multivariate statistics and work our way towards the complex models. So to do this, the course has 6 parts. So let me just delete this thing here. So course content. So the course content we have multivariate. It has 6 parts. So the first part, that's essentially in the first week, is a review week where we review a lot of things and we look into multivariate random variables and some multivariate distributions plus techniques to estimate parameters. This is pretty much standard stuff, and some of this you already know from my course. I mean, those who took my course last semester. So in statistical methods, so because of regression, of course, is also multivariate technique. So course content, multivariate random variables and techniques for their estimation. So then we'll deal in the part 2, we'll deal with transformations. That sounds a little bit boring at the beginning, but this actually links to things like latent variable models, latent variable models, and things like dimension reduction, and these are techniques that are very important in multivariate statistics, because multivariate statistics aims to describe the complex interdependency between variables, but if it's too complex we can't do anything, so we need to find simple models. And these transformation-based models lead to well-known things like PCA or CCA, so principal component analysis or canonical correlation analysis. So okay, so it works. So that's the second part. The third part will then focus on unsupervised learning. And that's basically clustering. So of course, so we have objects and we would like to put them into groups. And so we look into algorithmic and we look into probabilistic models. Probabilistic models to do this, or algorithms, including Gaussian mixture models, and something called the EM algorithm, quite famous. And for the algorithmic models, we, for instance, consider clustering algorithms like k-means or tree-based methods. So that's the supervised learning. And then after we, so that's part 3, then we look into supervised learning. Or otherwise known as classification. Or if we only deal with discrete response, but regression is also some sort of supervised learning. So, and we'll look into things like Bayes classifiers, LDA, QDA, etc. LDA, QDA, etc. So we look into estimation, high dimensional estimation, variable selection, and we look also into things like cross-validation, how to estimate prediction error, etc., etc. So you can see that these two, clustering, supervised learning, unsupervised learning, and classification, supervised learning, will form a large part of this course. Then next we look into measuring and modeling multivariate dependencies. So particularly we look into vector correlation, and into simple graphical models. Particularly Gaussian graphical models. And so far all of this has been linear. So in the last and sixth part we look into non-linear models. So non-linear models include entropy as generalized measure, in particular mutual information. So those who took the course with me last term, you know that entropy in Kohlberg-Leibler, divergence, they appear everywhere, and it's no surprise they appear here as well. And then we look into things like Gaussian processes, or let's start with the algorithmic random forest. So, random forest, then Gaussian processes, then neural networks. Of course, for those topics, these are very, very extensive and advanced topics. We'll just provide an overview. So, and then this would lead you into advanced techniques for later study. But you can see, so the purpose of this module is to provide the basis for you to understand these things, and to understand things like neural networks or random forest or entropy or Gaussian processes. It's good that you have a basic understanding of multivariate statistics, and this is the aim of this module. So I hope you look forward to this module, and also look forward to learning more about the implementation of these methods in computer programming. So we will use R and RStudio, and you will see also in the weekly notes guidance, learning guidance for this week, that if you look at the worksheet for this week, for week 1, that this gives you some instruction how to install R and RStudio. So we'll do everything in RStudio, and the reason for this is that, of course, we could do Python as well, but RStudio is very good because it allows you to, it has something called R Markdown built in. So this allows you to mix computer output text with the and graphics and everything in one document. So this allows you to write a little nice report, and with this report you can basically solve small problems and then present them to others. That's very useful, and I recommend everyone to use R Markdown to write the report for the coursework. So this first week, I hope you get started with the university, and you also get started with this course by downloading all the materials, installing all the computer stuff, and then I hope you enjoy the rest of the course, and then good luck and see you in the next video. So, bye bye.